Hey everybody, and welcome back to Front-End Expert. In this video, we will be going over the Web Worker API. So web workers are an API provided by the browser. So this isn't a core part of JavaScript, it is something that has been added to browsers to make our lives easier. And what the purpose of a web worker is it allows us to run code in a separate thread. So sometimes we have some code that's going to take a long time to run, but we don't want to block the entire page while that code is completing, and the way we can do that is using a web worker. So to show an example here, we have some basic HTML, and all it has is two buttons with the ID of slow and say hello, and they say slow operation and say hello. And then if we come over to webworkers.js, you can see that we first select both of the buttons, and then we add click events to both of them as well. So the slow operation function is going to iterate from 0 to a very large number, just to make the function take a couple seconds to run. And then we also have the say hello function, which logs out hello world. So if we come over to the browser and we click on say hello, you can see we log out hello world. And if we click on slow operation, it will take a couple seconds and then it will say slow operation finished. But now what happens if I click on slow operation, then immediately click on say hello? Nothing happened until the slow operation finished. So we had to wait for the slow operation to finish before my click on say hello actually took any effect. And the reason for this is that the slow operation function was still on the call stack. So until this function completes, nothing else can actually happen, so the say hello function could not execute yet. Okay, so now let's come back over to the JavaScript and let's see how we can fix this by using a web worker. So we can create a web worker inside of the slow operation function by saying const worker, and we can set this equal to a new worker, and this worker takes in a path to a file, so a JavaScript file. In this case, it's going to be worker.js, but this would be the path to whatever file you want to run in a separate thread. And now all we need to do is move the code from the slow operation function into the worker.js file. So what I'm going to do is copy all of this, and we can delete it from here. We can save this file, and we can come over to worker.js, and we can simply paste this in, and I will fix the indentation here, as well as move it up to the first line. And now when we save this, we can come back over to the browser, and you can see everything works the same way, but the difference is going to be that I can actually click both of these at once. So I can click slow operation and immediately click say hello, and the slow operation was not preventing say hello from running. The reason for this again is that slow operation was simply creating the web worker, which happened very quickly, and then the for loop from 0 to this large number was happening in the worker, which is in a separate thread. Now, one key point about workers is because they run separate from our main code, we can't do any DOM manipulation here. So for example, in worker.js, if I tried to do something like document.body plus equals and just add the string hello to the body, and we run this code again, so I click on slow operation, you'll see it's not able to actually add hello to the body. Instead, we get document is not defined. The reason being that in the worker, we don't have access to the document, so we can't do any DOM manipulation. Okay, but now sometimes we also want the workers to communicate with the main thread, and we can actually do that very simply. So let's come back over to webworkers.js, our main file, and we can start by sending a message from this file into the worker. And the way we can do this is using the post message function. So what we can do is we can say worker.postMessage, and this takes in whatever message we want to send. For example, let's send the number 10. Okay, so now we can save this, and let's come back over to worker.js. And what we want to do now is we want to actually listen to these messages. So we want worker.js to get the message from webworkers.js, which is the main file. Now let's go ahead and delete this code here so that we don't need to wait for our code to run anymore. And now what I'm going to do is add an event listener. The way we can do this is simply by saying self, and self is a reference to the worker global scope, which is very similar to the window object that we use in standard JavaScript files. And we can call the addEventListener method. So we can say .addEventListener, and the event that we want to listen to is going to be message. And when a message happens, we can call a callback function. So we can say event, and this will be an arrow function. And what we want from the event is the data. So for now, let's simply say console.log event.data. And we can add the semicolons in. And then we can save this, and we can come over to the browser, and we can click on this button again, and you see we log out 10. Now, it's also worth noting that we don't need the self dot here. We can also just do add event listener, and we could save this, and you can see this will work the exact same way. You also might see something like on message and setting this equal to a function like this. This would do the same thing as well. So we could do console.log event.data like this. And then we could comment out the add event listener code, save this, and we get the same result this way as well. Personally, I prefer the add event listener method. I think it's a little bit cleaner, but either one is perfectly okay. It is also up to you if you prefer to do self dot or just call the functions. I prefer to just call the functions in the same way that as when I call set timeout, I don't do window dot set timeout. I usually just call set timeout. But either option is perfectly okay. It is just personal preference, and I would just try to be consistent. Okay, so let's come back over here. We can delete this code, and we can uncomment out this code one more time. And what I want to show next is how we can send information back from the worker to the main JavaScript file. So the way we can do this is by calling the post message function, and we pass in whatever we want to send back to the main file. So for example, I could send in event.data multiplied by 10, which will be 100, of course. But you could imagine we could have some very complicated function we were running here, and we don't want to be blocking the main thread while we do it. And once again, post message is a method of the web worker global object. So we could as well do self.postMessage, or we can simply do post message. And then we can come over to webworkers.js. And what we need to do is we need to listen to this message. So we need to listen for when a message is sent back from the worker. And the way we do that is just how you might expect. So we can say worker.addEventListener, and this is going to be the message event as well. It can take in the callback function with the event. And in this case, let's simply console.log event.data once again, add the semicolons, save this. We can come over to the browser, click on slow operation, and you can see we first logged out 10 inside of worker.js, and then we log out 100 inside of webworkers.js when we get the message back from the worker where it had multiplied it by 10, giving us that value of 100. It's also worth noting that this happens asynchronously because it happens through events. So you can see if we come back to worker.js, the console log of slow operation finished happened before the log of 10 and 100. The reason being that the logging of 10 and 100 are happening in the callback functions of events. They are not happening immediately, so this waits for the call stack to be empty essentially before it's actually happening, as well as it has to wait for the information to be sent from the main thread over to the worker thread. And now there are a few other functions of the worker. One of the most important ones is going to be the terminate method. So we could do something like worker.terminate, and all this does is it says stop the worker from running, prevent anything else from happening, no matter where it was in execution. This simply terminates the worker. So if I save this and we run this again and click slow operation, nothing is going to happen because of the fact that I terminated the worker before it had a chance to do anything. Okay, but what I'm going to do now is come back over here and we can delete this line. We don't need to be terminating the worker. And what I want to look at next is something known as a shared worker. Until this point, we've been looking at dedicated workers, which means the workers are only accessible from the script that created them. But what we can do instead is create a shared worker, which can be accessible by different tabs of the same domain or even in iframes. Now, it is worth noting that a lot of browsers do not support this yet, so I don't really recommend using this in production quite yet, especially with mobile browsers. Almost none of them support it, but it is still a good thing to know about and something that could become more common in the future. So what we can do is replace the worker constructor with the shared worker constructor. And now the biggest difference of how we use a shared worker versus a standard worker is instead of simply saying worker.postMessage, what we're going to do is say worker.port.postMessage. So almost everything in a shared worker is going to be specific to a single port. That's sort of how the worker keeps track of who it is communicating with. And the same is going to be true down here for the onMessage event, but I do actually recommend with these using the onMessage syntax. So instead of @eventListener, what I'm going to do is say worker.port.onMessage, and I'm going to set this equal to a function, and we can take in the event. We could also leave this as an arrow function. It doesn't really matter, but we can set this equal to a function like this, and then we don't need this parentheses down here. Now, you don't have to do it this way, but if you don't do it this way, when you use ports, you actually need to start the port if you don't use onMessage. So when you use @eventListener, you would have to call worker.port.start, which is a method which simply starts up the port. But when we use onMessage, that gets done for us. So I do think it's a little bit cleaner this way, but if you prefer, you can still use @eventListener. Okay, so let's save this and let's come over to worker.js, and we need to make some changes here as well to allow this to be a shared worker. So instead of listening just to messages at the top level, what we need to listen to first is the connect event. So the connect event fires whenever something connects to this worker. And the reason we have this is there can be multiple connections, so we need to listen to each one of those connections and sort of handle them individually. Okay, and now inside of the event listener callback, what we want to do is first get the port. So we can get the port by saying const port, and we can do event.ports. And this is going to be an array, but it almost always just has a length of 1, since there's usually only one port per connection, so we can simply say ports at 0. And now to actually listen to messages, just like we did in the main file, we can do port.onMessage. And we can set this equal to a function that takes in an event. And what do we want to do inside of this function? Well, for now, we can just copy this code we already had, so we can move this inside of here. And now I will also delete this console log at the end. And I'm also noticing that we are missing the port.onPostMessage. So we can do port.postMessage. We can save this. We can come over here, click on slow operation, and this is working roughly the same way we had before. You will also notice the log of event.data didn't happen here. It actually does happen, but the browser is showing this console somewhere else, so I'm just going to delete this for now. Depending on what browser you're using, some combine the console in this main console. Others you have to go somewhere special to see the console of a shared worker. So just know that depending on what browser you're using, you may or may not see console logs when you are using a shared worker. Okay, and with that, that will be the end of this video on web workers. As a quick recap, the main idea here is that when you have a slow operation that does not depend on the DOM, usually you want to do it in a web worker. That way it doesn't block the main thread and the browser still works as you would expect. Now, of course, most of the time, when you have something that is taking up a lot of computational power, you do actually want to do it on the server rather than doing it in a web worker in the browser, just because the browser isn't going to be as powerful as your servers most of the time. But this is an option, and there are times when this can be very useful. So with that, I hope you enjoyed this video and I hope you learned something new. I'll see you in the next one.